I can see waving in the background.
I would have put a sign up. Or my YouTube channel.
They try to drive traffic to their own YouTube channels. Today I'm going to go through how we actually create a line which can move to any angle using graphics. So what we're going to do is we're going to build a new Windows Forms application. I'm just going to call it Experiment with Line. And then what I'm going to do is create a line which you can rotate to any angle at all. In order to do this, you need to have a bit of an understanding of some of the simple maths that is involved. It means knowing about Pythagoras, sine, cosine, tangent, although we're not going to use tangent for this piece of code, and what radians and degrees are. Obviously, most people know that you have 360 degrees in a circle. And we need to use that radian measurement when we're going through sine, cosine and tangent. Otherwise the calculations don't work properly in the maths that we use for the maths library. This is taking a rather long time to actually load. Getting there, getting there, getting there. Still creating projects. Okay, getting there eventually. Problem with using a virtual. So how are we going to do this anyway? First of all, we're going to wait for the form to load up. Secondly, we're going to need 2 points, the start point and the end point for our line. We're going to set a length, which is the number of pixels our line is in as a double, and which angle in degrees our line is currently running at. I'm also going to include some controls, so we're going to need to add some events onto our form to make that work. So let's load up the properties window eventually when we finally get there. It's really being slow today, not responding. Here we go. So on our form we're going to add a few events first of all by clicking the lightning bolts. I'm going to add a key down event. And this is the slowest it's ever actually been. Key down event finally loading up. There we go, finally. We're going to add a key up event. We're going to add an on paint, so we're going to control drawing directly to the screen. We're also going to add a timer from the toolbox, which is probably going to take another 4 hours to load now. Oh no, not too long. Still thinking about it though. Yep, it is actually going to be that long. Here we go. Slowly but surely, let's build it up. And what we're going to do is get a timer control. Just double click on that. I'm going to set the timer control to have an interval of 50 milliseconds. I'm going to enable it straight away and I'm going to create the on-click event. So we now have the form set up exactly as we need to. Now what we need to do is actually create some of the variables and things we're going to use. So I'm going to start with a point called the start point. And I'm just going to move it to 100 by 100 on the screen first of all. The end point will actually be calculated in the line, but for the start I'm just going to set it to 200 by 200. Now, as I said before, we need a length for our hypotenuse, our line length, which I'm going to set as 100 pixels. And we need a current angle, which I'm going to set to 0 degrees first of all. We're also going to use indirect control on the keyboard for increasing and decreasing the angle. So I'm going to have 2 booleans that say whether I'm pressing a key or not. Finally, what I also want to do is have a bitmap to actually trace my line, so I can actually see where the line has been as I draw around it to make sure it makes a perfect circle, etc. So to do that, I'm going to add a bitmap. Make it 640 by 480. I'm going to need to draw to this, so I'm going to add a graphics object as well. I'm going to call GFX. So to initialize all the components, the first thing I need to do is obviously double buffer everything. So I'm going to set the style to work with double buffer. So all painting WM paint, optimize double buffer, and set those to true. And then obviously need to initialize the components in the form, and then I'm going to set transparent color for my background. And set up where I get my graphics from. I'm going to take it from the, so I can draw directly onto the draw bitmap. Do I need to clear? I'm not going to clear at the moment, I'll leave it as is. So there we go, we've got ourselves a drawing that we can do and a bitmap. So what do we do with the actually changing, pressing a key? Well, first of all, when our key goes down, we're going to set the key, set the increase angle or decrease angle to true if the key code is the left or right arrow. So keys.right, we're going to increase the angle. If the keys.left, we're going to decrease the angle. It's being so slow. No, we're not responding again. Here we go. Angle equals true. When we lift our finger off the key each time, we're going to then change it to being false. So this is indirect control. All this is currently doing is being able to change the angle. Okay. So on the timer, we need to actually say what happens if increase angle is true. We need to increase the angle, obviously, which is we're going to do angle plus equals 1. We want to do a bit more than that though, because one of the other things we might need to check is see what the angle currently is. Because if the angle is 360, we actually want to set the angle back to 0. Now to do it with decrease angle is pretty much the same thing. Except this time we're going to decrease, obviously. So minus equals 1. And if the angle becomes minus 1, we need to reset it to 359. Okay, so at the moment all we're doing is increasing and decreasing the angle with our timer. Let's actually show it on the screen. So e.graphics, let's draw the string. And what I'm going to do is draw the current angle to string in a new font, which I'm going to do as Calibri, size 16, and I'm going to do it a new solid brush. Let's do colour black. Again, note American spelling on that, and I'm going to set it just about 10:10 on the screen. So that's all I'm doing at the moment is going to draw the current angle that I'm on, and that needs to say 16 just in case it's an error. So if I run this now, all it's actually going to have at the moment is which angle I've currently got my number set to. So it's going to draw the angle to string. It eventually loads up. There's the form, and if I press the right arrow key, left arrow key, nothing actually happens. Well, that's because I've forgotten to do something, which is actually refresh the screen, which was a bit silly of me. So let's just add this dot refresh on. And now when we refresh the screen on the timer, when I press the left arrow and the right arrow, we can see our numbers change to match what angle I wanted to be drawing at. Now comes the more complicated bits. First of all, the angle is going to be in degrees, and we want to convert it into radians. Well, we've actually got some nice equations we can use for that. So the first thing we're going to do is create a function which can convert from degrees into radians. So I'm going to set it as a private, it doesn't really matter. The numbers really need to be doubles rather than integers, and I'm going to do degrees to radians. And I'm going to obviously give it an angle, which I'm using a capital letter for, so it's not the same as the global variable. So what I'm going to return, or run, is the number pi, which I can get from math.pi, which obviously makes things a lot easier than having to actually do 3.141592.6.54. Divide that by 180 and then multiply that by the angle. That will give me the value of the angle in radians rather than degrees. Nice and easy, first of all. Next thing to do is to make the angle from radians back to degrees. Now the input angle will actually be in radians, and the only difference actually is quite straightforward. We just divide 180 by math.pi instead of having it divide math.pi by 180. So now I've got my degrees to radians and my radians to degrees as needed. This is where we then need to start using something called SOHCAHTOA. Some orphans have curly auburn hair till old age. Or the sine of an angle equals the opposite divided by the hypotenuse. Cosine of an angle is the adjacent by the hypotenuse. Tan of an angle is opposite divided by adjacent. What this means is, if I load up something really complicated like paint, if I've got a line like this, and I want to measure, that's a very bad line, I want to measure the angle like that, what I have to do to get that angle there is turn it into a triangle where this long line here is the adjacent because it's attached to the angle, and the shorter line here is the opposite. So I can break down, by knowing this angle here, how many pixels up and to the right I need to go to make a line appear to be 100 pixels at the right angle. So how do we do that then? Well, let's start with our sine angle. And we're going to give it the angle in radians. And all we return is math.sine, the angle, times the length that we actually have as our hypotenuse. Cosine is pretty much the same thing. So let's do a double cos angle. Math.cos. Make sure I'm using capital A's, otherwise it'd be the wrong one. So this returns the opposite of the x-axis. This returns the adjacent. I can't spell today. So, how do we do the actual calculation? We might as well do the calculation actually within the paint part. That makes life a bit easier. So what we're going to do is we're going to take our angle, first of all. We're going to convert that degrees to radians, so we get our value there. If we then sine that value, so sine angle, my degrees to radians angle, that will give me the x-axis, first of all. So that gives me the x point. So all I need to do is create a new point where unfortunately I have to convert to int 32 because obviously number of pixels is a whole number. That then gives me my x-axis, but then have to add on where the start point is. So it draws the line from the start point to the end point. Obviously I need another bracket here so that I'm converting that into the everything that's a double there then becomes an int 32. And I need to do something similar for the y-axis, except this time instead of being the sine, it's going to be the cosine. So cos angle, and obviously using the y-axis. Now the only problem is, on computers, we have the opposite problems for on graphs for the y-axis, where we go positive, very badly drawn positive, to 0 on a graph, and it's the other way around inside a computer screen. So what we actually need to do is set our y value to a negative version of the y value that we've got. So that gives us our endpoint, so we now know where our endpoint is, and we now just have to draw a line from the endpoint to the start point. I'm going to create a new pen, which is new solid brush, colour blue. Let's just do. I'm going to set it to a width of just 1 at the moment. And then I draw my line from the start point to the end point. Let's give that a view, just to check it's doing what it should do. It doesn't appear to be doing what it's supposed to. There doesn't appear to be anything actually appearing on the screen, does there? Well, that's because I'm actually drawing it to the graphics object, which is the image, not to the actual line. So what I need to do now is make sure that is actually drawing to the screen. And there we have our blue line that rotates round. And each time it rotates, it's still going to be 100 pixels in length, no matter which angle it appears at. Now I'm going to trace this using an image. So this is where the image bit comes in. Let's draw the image, called draw. I'm going to draw it at the 0, 0 location. And then onto this image, I'm going to draw the same line again. See, now this is where I do bring in GFX. I'm going to draw this one in red though, so that you can see it as different colour on the trace. And what this is basically doing is saving a copy of the last drawn line onto the graphic each time. So I can actually trace through exactly what path my line takes. So I can show that it's definitely 100 pixels all the time because it should produce a perfect circle. Notice that it doesn't fill in every single dot to make a solid circle, and that's because as you go further and further from the start point, the angle and the changeover to being a whole number actually does cause a problem. You get a starburst effect. You should actually have to set the angle as going up probably by 0.1 each time in order for it to actually make a solid circle. So if you want to change it to try out, obviously it'll take 100 times longer. We can just do 0.1, and now it's going to take a lot longer to actually increase the angle, but it will actually create a much more solid circle. As you can see, you can start seeing some of the rounding errors that occur when you go from doubles as well. But it does actually make a solid circle. It just takes a lot longer to produce just by using the mouse. And that's it. That's everything. That's how we create a angled line at any angle that you want to create.